Hi Ella, it's Coach Mary. How are you? So question number 12 that you asked me about. So it says a wire 10 meters long is to be cut into two pieces. One piece will be shaped as an equilateral triangle. The other will be shaped as a circle. So based on what I showed you the other day, I'm kind of glad we went over that. We did one that was similar to this. But here we've got this wire. Let's pretend that this is my wire. Sorry, it's not so straight. And we know we're cutting it into two parts. We just don't know their size, okay? One of them is going to be thinking of the equilateral triangle, its length, okay? And the other one would be the circle. So here's my circle. So if I have an equilateral triangle with all the sides being x, well then this length of it would have to be 3x because that would be the perimeter of the equilateral triangle. And if the whole thing is 10, then the circle would be, its perimeter or circumference would be 10 minus 3x, okay? All right, but it says express the total area enclosed by the piece of wire as a function of the length x of a side of the equilateral triangle. Okay, so we know that the area of a triangle is base times height divided by 2. Okay, so let's find the height of this triangle. So we know that if it's equilateral and I drop an altitude, this is a 60-degree angle, so this would be 1/2 x. And so this would be x root 3 over 2, okay? Because you multiply 1/2 x by root 3 in a 30, 60, 90 triangle. Okay, so now we've got to get the area. So we have our base of x, and we have our height of x root 3 over 2. And actually, we divide that by 2 is the same thing as multiplying by 1/2. So I'm actually going to multiply that by 1/2 because I think it's a little bit easier, okay? All right, so that's going to give me x squared root 3 over 4. And that actually is a formula for the area of an equilateral triangle. So that's the area of the equilateral triangle. Now we have to find the area of the circle as well, okay? Now the circle, its circumference we know is 10 minus 3x. Okay, so, and we know that the circumference of a circle is 2 pi r. So 2 pi r equals 10 minus 3x. Sorry, I wrote pi up here for some reason. Let me erase that. Okay, so I'm going to divide by 2 pi. So my radius, although ugly, is 10 minus 3x all over 2 pi. Okay, so now I can find the area. So the area would be pi r squared. Pi, and then 10 minus 3x all over 2 pi squared. Okay, so it wants the area of the enclosed by the figure. So we'd add those two areas together, okay? So we would have the area of the whole figure would be root 3, I'm going to write it like this, root 3 over 4x squared plus 10 minus 3x squared. I'm going to actually simplify the bottom and make that 4 pi. We can't really square pi because it's irrational, but I could square that too, giving me 4 pi. So that's the area of the entire figure. Okay, so then it asks about the domain. Well, if we're thinking about this, we're talking about area and a segment here. Then we know that the domain, the x values, the smallest x value we can put in there would be 0, okay? So part B, okay? My x would be 0, okay? And if I put 0 in, then the largest x I would get would be 10/3. Okay? All right, and then the last question says graph A, or A of x, and for what value of x is the smallest? Well, it's really yucky, Ella, but if I go to Desmos and I graph it, which I've already done for you, you can see that, let me move this over a little bit so you can see it. I plugged in 3/4 x squared plus I knew it was somewhat quadratic, right? And I can see that it asked for what value of x is A the smallest? So that would be the vertex. That would be the smallest area. So at 2.077, that x value, I will have the smallest area because area is the y-axis. Now, if you didn't graph it, you could do negative b over 2a with that equation. It would just be really, really yucky. Okay? So hopefully that helps. And if you need any more help, let me know.